In this example, we've got three forces acting on a boat, and we're told its weight, its mass, and the acceleration of the boat. And we're asked to find what one of the missing forces is, that force 2. So we're going to use the formula, F equals ma, and F is going to be a vector, and A is also going to be a vector. Now remember that F is the resultant force. So in this case, to work out the resultant force, we need to add together these three vectors, F1, F2 and F3. So the resultant force is going to be 80, 50, plus 10p, 20q, plus minus 75, 100. So let's write these, let's add together these three vectors and write it as a single vector. So we're going to have 5 plus 10p horizontally, and vertically we're going to have 150 plus 20q. So now we can substitute that into F, and we also know that A is equal to 0.8 minus 1.5. So we're going to have 5 plus 10p, 150 plus 20q, equals m, the mass of the boat is 60, times by the acceleration, which is 0.8, and minus 1.5. So in order to solve this vector equation, we can look at the top components, the horizontal components, and the vertical components. So if we look at the top component, we've got 5 plus 10p equals 60 times 0.8, 48. And we also know, in fact, from this equation we can find out what p is quite easily. So we know that 10p equals 43, so p equals 4.3. And let's look at the second equation that we can get from the vertical component. We know that 150 plus 20q equals 60 times minus 1.5, which is minus 90. So we can solve this to find out what q is. So 20q equals minus 240, and if we divide by 20, we get q equals minus 12.